we describe how different chemistries can be used to improve the serviceability of fabrics. Traditionally, fluorochemicals were used to provide superior water and soil resistance. Fluorochemicals increase the surface tension, causing water and/or oil to bead. The same repellency also prevents soils or stains from entering the fabric and forming a bond. Due to environmental and safety concerns, fluorochemicals have been replaced with alternative chemistries. These include, but are not limited to, highly branched hydrophobic polymers with dendritic structures. Siloxane silicone products are also effective as a fluorochemical replacement for water repellency. Due to their open molecular structure, they allow water vapor to pass through the substrate where water molecules are too large to pass through. This provides a breathable water-repellent fabric. It should be noted that these fluorochemical alternatives provide excellent water-repellent properties. However, there is currently not a comparable alternative for oil repellency to replace fluorochemicals. Contemporary lifestyle dictates that we look neat while we work hard and play hard, so fabrics can be treated to resist wrinkling, to retain a smooth appearance, keep creases and pleats in place even after laundering. Currently, the most popular chemistry used to resist wrinkling is resin-based. Many factors related to chemical reactions influence wrinkle-resistant properties. The reactant concentration, the catalyst type, and the catalyst-resin ratio are of utmost importance. There are three main methods of resin application: pre-cure, fabric post-cure, and garment post-cure. The pre-cure process occurs after the fabric has been dyed. First, the resin, a catalyst, and softener is patted onto the fabric. Then the fabric is dried and cured at an elevated temperature. After this, the fabric is cut and sewn. The process is quick, inexpensive, and reproducible. Following the pre-cure, the garment is assembled and sent to the customer. Because the fabric was cured prior to garment assembly and has a memory for the flat, smooth state, creases and slacks will not be durable. In the post-cure process, the order of events is different. It begins the same way, by patting on the resin and drying the fabric on a low temperature. Next, the garment is cut and sewn. The desired creases or pleats are firmly pressed into the garment. As the final step, the treated garment passes through an oven to cure at higher temperatures so creases are permanent. Instead of applying finishes to fabrics, resins can be applied to a completed garment. One advantage in garment application is that the cut waste does not have the chemical treatment. The first garment application method is garment dip. Garments which are first cut and sewn are immersed in a chemical bath. After this, the garment is tumble-dried at a low temperature, which also pre-shrinks the fabric. Next, the garment is pressed either flat, or creases or pleats can also be made. Finally, the garment goes to an oven for curing, which is when the resin chemically reacts. A benefit of this process is better inventory control because garments are finished only when orders arrive. The garments produced by applying resins and garment dipping shrink less and have better fit. There is a softer hand than that produced by the conventional post-cure method. A newer and more sustainable method associated with garment resin applications is metered addition. With this approach, cut and hand-sewn garments are sprayed while tumbling in a garment machine. There is much less waste in chemicals because a metered or measured amount of water and chemistry, just what is needed, is sprayed on the garment. You've seen many different ways that garments or fabrics can be treated with chemicals to improve wash and wear and wrinkle resistance. Another way to soften and improve the appearance of cotton fabrics is with the use of cellulase enzymes. Found in all living organisms, enzymes are specialized proteins which quicken natural reactions. Safe and easy to use, enzymes attack and degrade specific materials under mild conditions. Enzymes replace harsh solvents and other organic compounds used to finish fabrics. There are several different types of enzymes that are used in textile wet processing, and they are specifically engineered to create certain attributes. Cellulase enzymes hydrolyze cellulose, which offers improved effects including softness and better color washdown. Also, cellulase enzymes remove cotton surface fiber, or fuzz, that makes fabric look worn and can cause pilling. Cotton fabrics treated with cellulase enzymes and subjected to mechanical agitation are less likely to display these undesirable surface characteristics. Cellulase enzymes can also be used on denim to create a stone-washed look without the use of pumice stones.